to today's technical mathematics lesson. My name is Matsidiso Kongwani. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Okay, grade 12s, our lesson for today is on revision of paper 1. We know that when we look at paper 1, we are having specific topics that falls only under paper 1. So under paper 1, we have the first topic, which is algebra, and then the weighting thereof for that particular topic on your question paper, it will be 50 plus minus 3 marks, and then followed by functions and graph, and then functions and graph will worth 35 plus minus 3 marks, and then thirdly followed by the finance, growth and decay, which is 15 plus minus 3 marks, and then lastly we are having differential calculus, and then together with integration, and then that worth 50 plus minus 3 marks. So that is the structure of your paper 1, and also the sequencing of the paper is exactly like it is noted there. The first question will be on algebra. At the end of algebra you have functions. End of functions you have your finance. After finance it is then that you will have your differential calculus and integration. And then now at the back of your question paper, remember you are having an information sheet, and then now we are having the formulae that we are using only for paper 1, and then we are having the one that are applicable for paper 2. And then herein we are having formulae that will be applied for paper 1. And then now we have clustered this according to topics now. At the beginning of your information sheet, grade 12, the first formula that is starting is a quadratic equation. So we have clustered this according to topics now. The first 2 rows will be having algebra, functions and graph formulae. So under algebra, functions and graph, we are having a quadratic formula, as you can see indicated, that followed by the turning point, the x turning point formula, followed by the y turning point formula. You know, if you don't want to substitute in that formula, you can substitute into the original given formula, but it must be of a quadratic equation. Okay, and then now we are having exponential equation. Remember, they always go together. Exponential and the logarithm equations, they have a relationship. You know, even in functions, we know in order to have a log function, you are depending on the exponential function. Vice versa, the inverse of the log will be the exponential, and so on. And then now we are also having an exponential equation on our formula sheet, which is 12, remember we're looking at the relationship of the exponential equation with the log function. As we've indicated that the equation for exponential is a to the power x, and then we have equal to b there, and then the log function is x equal to log b base a. And then with this condition now, remember a must be greater than 0, meaning that the value of a here must always be positive. And then now a must not be equals to 1. It must be any value that is greater than 1. And then now b must also be greater than 0, meaning b must also be positive. Those are the conditions when we are dealing with this particular equations. And then now we have finance, growth, and decay formulae. And then under finance, growth, and decay, we have 3 classes. The first one, we talk to simple interest. And then with the simple interest, we are using the formula A is equal to P into 1 plus NI. As you look at this one, it's a linear one. You look at N there, N is not on the exponent. Look at N is not on the exponent. Therefore, simple interest is having a relationship with a straight line or a linear equation. And then now when you look at the compound interest, now look at N. Our N is now an exponential. That means the compound interest is having a relationship with the exponential equation. And then now the first two here, we use it for simple interest. And then the next two there, we use it when we are dealing with the compound interest. And then under finance, lastly, we are having the formula for the effective rate. So the effective rate is equal to 1 plus I nominal rate. The nominal is the actual interest that is given to you. And then over M here, and then also exponent M. M is talking to the compounding. Compounded monthly, it will be 12, 12. Compounded quarterly, it will be 4, 4, and so on, grade 12. And then now followed by a minus 1. So we are using this when we are calculating what? An effective rate if given the nominal rate. Or you can calculate the nominal if we are given the effective rate using that particular formula. The next class, we are having the differential calculus. Under differential calculus, we have only one formula, which is the first principal formula, which states that f derivative of x is equal to the limit of h approaching 0 of f at x plus h minus f at x over h. Look at that, grade 12, the equal sign is just immediately before your limit. You cannot put an equal sign after a lim. The notation will be incorrect. Then you will be penalized 1 mark for incorrect notation. And then now the lim must always be there on your formula. And then look at f derivative. There's a dash there that is indicating the derivative. Those are the things that give you problems, grade 12. Sometimes you'll find that that dash is missing, or an equal sign is after the limit, or the limit is or not on the formula. Please double check with your formula sheet that everything is correct. And then lastly, on paper 1, we are having the integration now. This will assist you to answer all your integration by just relating the type of the question with the rule that is given here. So the first class here, we are having the first rule here there, which is x to the power n. This one is only indicating that if there's a constant number before your x. And then we have rule number 2 there, where we are having a fraction now 1 over x to the power 1. Then you apply that one. And then lastly, we are having a to the power x there. Okay, those are the 3 integrational rules. And then remember now, grade 12, you can send your questions or your clarity seeking questions to our WhatsApp number 079-454-9535. Repeat, 079-454-9535. You are more than welcome, grade 12, to send your questions to that particular number. And then we have a strategy here, the 30% strategy. To target 30% in your paper, what must you do? Number 1, you ensure that you have 80% for your pet, 80 or more. And then now the focus on the content, and then also the marks that you can target in order to get a basic 30%. Therefore, with algebra, remember algebra, the total is plus minus 50 there. So you can target plus minus 22 by looking at the quadratic equation, simultaneous equation, the literal equation, and substitution, the binary numbers, exponents, and sets. You can repeat and repeat that grade 12 until you get your plus minus 22 marks. And then on functions and graph, the total expected is plus minus, or the weighting for the whole topics on your paper is plus minus 35. And then now if you can target 30 there by checking all the properties of your functions from grade 11 functions, then you'll be able to get that 10 plus minus 10 marks. And then with finance, growth and decay, remember the weighting, total weighting for finance on your paper is plus minus 15. If you can manage to get plus minus 7 marks grade 12, you will reach that 30%. And then now we are talking the basic growth decay and the effective nominal rate. That means in this case we are expecting you now to be more in practice with the growth, decay, and the effective and nominal rate calculations. Lastly, we are having on paper 1, calculus and integration. The weighting for that is plus minus 50, and then we are expecting you to get plus minus 14 in order to reach a 30%. So then you can master your first principle, look at the rules of differentiation, and then the basic integration. Remember, the formula sheet will assist you in terms of the integration. And then now let's talk to finance, growth and decay. Remember we said it's 15 plus minus 3 marks. Now with the finance, there are key ways that you must look for. Number 1, in order to select whether the formula that you need to use, is it of simple interest or of compound interest, you must look for the keyword simple interest if it is a simple interest, or you must look for the higher purchase if it is on higher purchase. That means now it's a simple interest. Or another keyword that is indicating simple interest, they can say on a straight line basis or on a linear base. You must know they are all talking to simple interest. You are forced to use simple interest by just identifying those keywords. And then which keywords can you look for when you are looking for compound interest? We look for the word compound interest on your statement, or you can look for the reducing balance. Reducing balance is referring to compound interest. Thirdly, when we talk population growth, we are talking to the compound interest. And then when we talk to the inflation rate, we also refer to the compound interest calculation. That simply means grade 12 now, compound growth, compound decay, we are talking to the compound interest. And then now there are cases whereby you need to use a formula that is a plus or the formula that is having a minus. For example, A is equal to P into 1 minus IN. Or if it was a compound one, it will be A equal to P into 1 minus I to the power N. When do I use a plus? And then when do I use a minus? There are key words that are guiding you on your statement. Number 1, if you see the word increased, accumulated, the growth or appreciation, you must know that you are dealing with the plus calculation. Increase, accumulate, growth, appreciation. And then when you talk to the minus one, we are looking at the keywords decreasing, decay, depreciation. The value is reduced or a decay, therefore it's a minus formula. Remember, number 1, you start by identifying does it fall to simple or compound, and secondly you check now, do I have to take a plus formula or a minus formula by looking at those keywords. Okay, grade 12, I hope we are still together. And then now let's look at the first activity there. They say a car engine overheated at an increasing. Can you see the keyword now? Increasing. That means it's a plus formula. Increasing compound. That means we are using a compound interest. It's a plus formula. It's a compound interest because there's a compound rate there. And then what is our rate? The rate is 26% per hour due to a leak in one of the water pipes. The initial temperature before the engine overheated, the temperature was at 75 degrees Celsius. And the question is, determine the temperature of the engine at the end of how many 3 hours if it is continuous to overheat at the same rate. Now, grade 12, we have identified that we are depending on the compound interest of a positive now. So now if you look at the compound interest now and you want to determine the temperature of the engine at the end, that means we are looking for the value of A. And then to calculate A, as you look into the formula, you can see that you need the value of P. Let's collect the data now. You also need the value of I. We need the value of N. So if we can have those three, then we can be able to find the value of A. And then what is our initial P value here? They say the initial temperature. Remember, P is the principal value, the initial value. So they say the initial temperature before the engine overheated, it was at 75 degrees Celsius. And then it is increasing compound rate of 26. The engine is overheating at an increasing compound rate of 26%. So this is at 26%. And then now, for how long? Determine the temperature of the engine at the end of how many? 3 years. Therefore, the end value will be 3. Now, grade 12, you have everything that you need in order to calculate A. Now we can bring in the compound interest formula, of which is a positive one. Therefore, it's A into P, 1 plus I to the power N. And the next step now is our substitution. We are looking for A. What is the P value? 75 into 1 plus at an interest of 26%. And then value of N is equal to 3. Then you'll be having your first mark for substitution, grade 12, if everything is substituted correct. And then now you can put that into your calculator. Do not partially simplify this. Put everything into your calculator. There is a percentage button on your calculator there. And then this gives us an amount of 150.3 cents. Okay, remember, after a comma we are taking only 2 digits. There's no way that we can have cents that are more than 2 digits, grade 12. And please round off your answer only at the final answer. When you do finance, no partial rounding off in between. We only round off at the final answer to be 100% accurate. And then therefore the mark allocation for this one, it will be 1 for the correct formula, that you know that you are dealing with compound and you have selected the correct compound interest with the plus sign here. And then the second mark will be substitution into the correct formula, and the third one will be for your answer. So that question, it worth 3 marks. Okay, the next question. An engineering company purchased a printer, and then this printer cost 81,000, and then the value of the printer depreciate. Can you see now? Depreciation, that means we are expecting a formula that is minus. Those are the keywords, grade 12, that you must target. At the rate of 20% per annum using reducing balance. That is another keyword. Remember, we indicated that if it is saying reducing balance, it's what? It's a compound interest. Now we know it's a compound interest formula of minus. Okay, and then now let's now look at the question. Write down the value of the printer if it depreciated to 1/3 of its original value. Remember, the original value is 81,000. Now this value has depreciated by 1/3, okay, of its original value. And then what is the new value of the printer now after depreciation? So now let's calculate that. Remember the initial value now, our value will be equal to the 81,000 that we were having initially, minus, remember we have depreciated by 1/3 of the original 81,000. Or you can start by calculating the 1/3 of 81 and then subtract that amount from the 81,000. And then this is giving us how much now? The 54,000. That means now this printer, initially the value was 81,000, because now it has depreciated, the value gone down, and then this is now the new price of the printer. And then question number 2. So this one will worth only 2 marks for the method and for the answer. And then question number 2, determine how long it will take for the printer to depreciate to 1/3 of its original. Okay, how long, that means you are looking for the value of what? The value of n. And then now we are using the compound interest formula that has depreciated minus I to the power n. And then what is the value of A now? A is the depreciated value now, because we have started at 81,000. Now the value has depreciated to 54,000. So now the value will be 54,000. And then the P was 81,000 into 1 minus, let's check the rate now, is at 20%, 20% rate. And then we are looking for the value of n. Can you see our n is an exponent now, grade 12? Right. But firstly, what must we remove? The 81,000, because eventually we want to calculate that n there. So we are going to divide both sides by the 81,000. Then this 81,000 will cancel that one. Then on the left hand side we'll be having 2 over 3, the simplified fraction of that. And then on the right hand side now we have 1 minus 20%, which will give us a 4 over 5. And then this is to the power n. Okay, and then from here, grade 12, we want to bring n down. So we bring along our logs in order to assist us. And then when you bring a log there, this will be log 2 over 3. And then our base now, this 4 over 3 here, will become a base there, 4 over 5. And then now that n will come down. And then now you put that into your calculator and check the n value will be equal to 1,82 years. That means it's 1 year and few months then. Okay, right. There is no any restriction on how to present your answer, so you are more than welcome to leave it in that format. Right, and then now, this is a high order question. Let's look at the question now, grade 12. We have a municipality plans to upgrade a clinic. And then we are upgrading a clinic when? After 5 years, in 5 years time. Starting on 1st of February 2028. The upgrade cost will be 95,000. The cost in order to upgrade that clinic, it will cost us 95,000. The municipality plans to invest in a savings account as follows. Right. 30,000 is to be invested from the 1st of February 2023. That means that is the starting of the investment. We will be starting our investment from 2023 with the first value that will be deposited, 30,000. Remember, we want to save for 95,000 because in 2028 we need a 95,000 in order to do what? To upgrade a clinic. That means this is a timeline type of equation, okay? Timeline question. And then now look at this now. Our investment will start in 2023, 24, 25, 26, 27, 28. That means grade 12 in total we are having an investment of 5 years, because now we want to start by 1 February 2028 with our upgrading of the clinic. So now we want to invest as in now 2023 in order in 2028 we can have an amount of 95,000. And then now let's continue with the statement now. So is 30,000 deposited in 2023, and then a further 20,000 is to be invested on the 1st of February 2025. That means we are investing 30,000 and it remains in your investment. By 2025 we add in a 20,000 into the invested amount and it remains there. And then the next statement says another amount, 10,000, is to be invested by 1st February 2026. And then now when you look at the interest rate for the first 2 years will be 10% per annum, and then it is compounded monthly. Thereafter the interest rate will change to 12% per annum compounded semi-annual. That means this 10% rate will only be for the first 2 years. Remember, our investment is for 5 years. So for first 2 years it will be at 10%. So for the remaining 3 years, that means it will now change to 12%. Now let's put the whole information on a timeline so that we can have a clarity of what is happening here. Right. We are starting our investment in 2023, and then by depositing a 30,000, and then this 30,000 remains into the investment up to 2025, and then in 2025 20,000 is added. A deposit of 20,000 came in, and then this money remained in that investment. And then in 2026, okay, after a year here, in 2026, another 10,000 is to be invested. They are adding 10,000 again into the same investment, and then that is the last deposit. We have a 30,000 deposit there. We have indicated a 20,000 deposit and the 10,000 deposit. And then remember, we said this investment will last up to 2028. That will be the last month of investment. So we are going to withdraw the money or check, are we at 95,000? Are we ready for the upgrading of a clinic? Now let's check now grade 12. The interest rate for the first 2 years. Remember, we talked 2023, 24, 25. That is our first 2 years. 2023 to 2025, that is our 2 years. And then within these 2 years, our interest rate is equal to 10%. And then it is compounded monthly. That means it will be divided by 12 because it's compounded monthly. Remember, when you are compounding there, n will also be affected. Now it will be times 12 also there. Okay, so we are relying on that for the n value, and then for the I value we have this I here for the first 2 years. I hope we are still together. And then thereafter the interest rate changes to 12%. That means from 2025 to 2026 now, it's a period of a year. Okay, it's 2 years initially there, and then we have added another year, is 3 years. So for the last part here, we'll be having 2 years remaining here in order to cover our 5 years. And then now remember, after 2 years, the interest rate is changing. So for the remaining, the 1 year and the 2 year, it is now taking a 12% interest rate. Now let's look at that. For this one, I will be equal to 12%, but it is compounded semi-annually. That means it's divided by 12. So also 1 year will be multiplied by 2, okay? And then n is equal to 1 times 2 there. And then also for this one, remember, is the remaining years, it will also take the 12% rate. So our I will be equal to 12%. Remember, it is compounded semi-annually, it is divided by 2. And then for 2 years, we also multiply that by 2. That will be the value of n for this period here, and the value of I for that one. The value of n for that one, and the value of I for that particular part. Basically, grade 12, after putting this on timeline, you can clearly see that you are expected to have almost 3 calculations. So now these calculations can be presented in only one timeline formula or calculation method. And then now in order to find the final amount. Right, let's put that into the equation now. It's A equal to, we started by investing how much? The 30,000, which is that one. Okay, and then now this is represented. And then remember, we have formula of compound 1 plus I to the power n. It will be 1 plus, what is our I in this case, is 10% over 12. And then for n value, we are having 2 times 12 there. Correct? That is your first calculation. And then it will give you the amount of value within the first 2 years. And then remember, after 2 years, we are depositing in at 20,000. So after this amount, we will be adding a 20,000 there into the amount accumulated with interest. And then the whole amount with the 20,000 added on, this big one now, is now invested again for a period of 1 year now, from 2025 to 2026. So we are investing this for another period. So that will be 1 plus 12% over 2 is for this interest of 1 year here. And then now remember, our n here is 1 times 2. And then now after that calculation, we are adding a 10,000. Do you still remember? Grade 12, after investing this amount here, this is the amount in our account. We now put in a 10,000. That is that 10,000 there. And then whatever value, the whole value we are having, we are now investing for the last time for the remaining period of 2 years. So we are taking this value here, investing it for the last time. So the last investment will be for 1 plus, what is our I, still 12% over 2. And then now to the power n, which is 2 times 2. And then now you can put everything into your calculator, grade 12. And then the final answer that we are expecting as we are calculating this together with you, the total amount that we'll be having is the 92,929. Remember, you can now round off your answer because we are at the final answer, and 59 cents. Now let's compare now. Remember, the question says determine whether the municipality will be able to save enough money for the clinic upgrade at the end of the 5-year investment. Yes, we have invested this money according to the types of different investment and different rates, and then eventually after 5 years in our account we found that we have now 92,929.5 now. But now remember, our target was 95,000. Have we reached the target grade 12? No, we are less than that because we are expecting to have a 95,000. That means this money is not enough, because the question was saying determine whether the municipality will be able to save enough money for the clinic. The money is not enough, okay, because we are expecting the 95,000 and we are seated at 92,929 rand 59 cents. Okay, that is the timeline. The easy way is to start by presenting your information on the number line, breaking it with understanding grade 12. You are more than welcome also to calculate it partially. Take this part, find the answer. To the answer, add the 20,000 and then that amount invested again for 1 year. Get the answer. After getting an answer, add the 10,000 and then that amount invested for the last time with the 2 years remaining. It will still give you the same answer as ours, but we must be careful that do not round off in between your calculation. Your sense, if you are having 5 digits, you have to put it like that until the final answer. It's only where you can round off. Rounding off in between will affect your final answer. Okay, that is your financial mathematics. Remember now, this simple interest and the compound interest can be given to you in terms of a graph grade 12. You must know if it's a straight line, it's a simple interest. If it's an exponential graph, you must know it is relating to the compound interest. Okay, let's move on to the second topic here. We are looking at the differential calculus, and then the first question is on first principle. Remember, we have our formula from the formula sheet that is stating that the f derivative of x is equal to the limit of h approaching 0 of f at x plus h minus the f at x and then all over h. Now, if you look at this formula, you need the f at x, of which is the one that is given to you. And then if you continue there, you can see that you also need the f at x plus h in order to answer that question. So now the question says that determine f derivative of x using the first principle. So now, with the technical math, it's very easy. The answer is already there. We know that when we are differentiating this using the first principle, we are expecting our answer to be 7 over 2 there. We are expecting that the f derivative for this question will be 7 over 2. That means always your answer will be the coefficient of x then. But you are forced to use the first principle. You can't use the rules grade 12. Okay, otherwise it's a 0. Right, let's look at the question again. We said we are having the f at x. We need f at x plus h before we can go into the formula. Okay, let's look at the f at x plus h now. F at x plus h, this simply means now where I am having an x, I am going to substitute all my x with the x plus h. Then this will be equal to 7 over 2. There I have an x, therefore it will be x plus h plus 5. After that, to simplify, We have fx plus h on the left. This will be 7 times x, which is 7 over 2x. 7 over 2 times h is plus 7 over 2h plus 5. Do not multiply the 7 over 2 to 5, grade 12, because 5 is not inside the bracket. We are only distributing 7 over 2 into our bracket. 5 is not part of the bracket. Please, that is a misconception, a mistake that is done by most learners. Do not multiply a 5 in. So that is the f at x plus h. And then now we can go to our first principle formula. It's f derivative of x is the limit of h approaching 0. And then let's substitute now. It's saying f at x plus h. Okay, we have 7 over 2 x plus 7 over 2h plus 5. And then there's a minus there. There will be minus. And then minus our f at x. The f at x is a binomial, 2 terms. Therefore, we need a bracket there. That will be 7 over 2x and the plus 5 all over h. The next step is to remove the bracket. We remember notation, limit of h approaching 0 must always be there. We have 7 over 2x plus 7 over 2h plus 5. Then we bring negative in, distribution of negative. It will be minus 7 over 2x, and then we end up with minus 5 there. Everything over h. Do not forget your h on the denominator, grade 12. Now, look at this now. On top, everything without h will disappear. There will be a cancellation of subtraction there. This is 5 minus 5. Can you see the 0? We have 7 over 2x minus 7 over 2x. They must cancel only if they have different signs to give you a 0. Can you see what is left is only with an h? So we have the limit of h approaching 0. And then we have 7 over 2h over h. Then the h will cancel the h there. So your answer will be that 7 over 2. Look at that, grade 12. When you write your answer, you don't write that limit of h approaching 0 because there's no h anymore on your equation. Okay, you just write the answer 7 over 2. If you can put a limit of h approaching 0, it's a notation error again. You must be careful around that one. Can you see what we have predicted before that the answer will be 7 over 2? That is true. We end up with a 7 over 2. So the answer is already there. Grade 12, yours is to find it, okay? Right. Next question is still of differential calculus. We have rules of differentiation. Immediately after the first principle, you'll be given one question on first principle, followed by the rules of differentiation under differential calculus. So now, do you still remember your rule? It says that if you are having f at x equal to ax to the power n, if you are deriving that one, the n will multiply with a there, that will be n a x, and the n exponent 1 must be subtracted. That is what we will be applying. Multiply and subtract 1. Do not mix with integration. Remember, integration is plus 1 plus 1. Calculus, differential calculus is a multiply and subtract. Multiply and subtract from the exponent. Please, grade 12, do not mix them up. And then now let's look at the first one. Determine, number 1, f derivative of x if f at x is equal to minus 8x. Do you still remember your rules? If this is to the power 1, that means your answer will just be your coefficient there, which is minus 8. Done. 1 mark. Okay, move to number 2. With number 2 now, remember when you are deriving, you need to ensure that you do not have a variable on the denominator. No letters on the denominator, grade 12. So now we are going to remove this x and take it up. Remember how we're going to do that. Now we take this to its initial fraction form. This was x to the power 4 over x squared plus 9x over x squared before we take the common LCM, which is x squared there. And then now from here, look at the notation here. I am still using that y as it is because I have not yet started deriving. Okay, and then now we are busy simplifying the y equation. We are not yet deriving. So when we are busy with simplification, we still write a y. Okay, so now the application here will be of exponential rules. When you are dividing the same base, you do what, grade 12? You subtract the exponent. That means it will be x to the power 4 minus 2, which is x to the power 2 there. The next one, we are having the coefficient 9. Remember, it's 9 over 1, still 9. And then now, dividing the same base, you subtract exponent. This is x to the power 1. Then it will be 1 minus 2, which is minus 1. Therefore, it will be x to the power minus 1. Can you see now everything is on the same level, nothing on the denominator? Then you can now start deriving. You cannot derive with x squared on the denominator, grade 12. Right. Now, because we are deriving, you tell us that I am now deriving by writing notation dy dx as it was indicated there is equal to exponent times 1. That is 2 times 1, and then x to the power 2 you minus 1. That is the method now that I've talked to earlier on. And then now, then we have minus 1 times 9, that is minus 1 times 9. And then we have x minus 1, we subtract 1 again. So now we have applied the rule. Let's simplify now. We have 2 x to the power 2 minus 1, which is to the power 1, it's fine. And then for this one is minus 1 times 9, that is minus 9. And then it's x to the power negative 2. You can leave your answer there, grade 12, or you can get rid. Sometimes an examiner may say, get rid of negative exponent on your answers. That means now you need to continue if that is the case. And leave a minus 9 because it's not affected. The negative is only on this part. So now we'll take this back into the denominator there. Then it will change to x to the power positive 2 now. Then that is our final answer. So the first mark will be for this simplified, where you are getting rid of the denominator. And the second mark will be for first derivative. The third mark for the second one derived there. So this total mark will be 3. Number 3, we have a dx now. Can you see, grade 12, we have unfolded different ways of notation. If it is f at x, you end up with f derivative of x. If it is y, it will be a dy dx. And then we are given now in number 3 as dx into brackets, the square root of x plus 8x, everything squared. We cannot derive when we are having brackets there. Can you see that? There are 2 brackets of that. That means we need to simplify those brackets before we can start deriving. As we have not yet started with deriving or finding the derivative, you leave this dx as it is. And then now we are dealing with the brackets now. We are having 2 brackets. Remember, square root of x is x to the power half. And then we have a plus 8x, and then x to the power half, and the plus 8x there. And then now, busy multiplying the bracket, you still write your dx, grade 12. It must not disappear yet. Ne? It must not disappear. When you are simplifying, that dx must always be there. Now let's start multiplying. Is x to the power half times x to the power half. Multiplying the same base, you add exponents. That means it will be x half plus half, it's 1. And then is x times 8x. And then 1 times 8, it will be 8. And then you are multiplying your x by x, same base, you add exponent. That means it will be half plus 1. And then that will be x to the power 3 over 2. The same applies with 8x times x to the power half, that is plus 8x to the power 3 over 2. And then now lastly we are multiplying the 8x times the 8x there. 8 times 8, that is 64, and the x will be x squared. Then we have our bracket multiplied out. As we look at that, we are having like terms there because they have x to the power 3 over 2, both of them. Then we are going to add those two like terms. You still have your dx because you still have something to simplify in the bracket. So that is dx into x, and the 8 plus 8 is 16, but this is of family x 3 over 2, and then plus 64 x squared. Happy now we are done with simplifying. We can now start deriving only after thorough simplification. Now because we are starting with the derivative, this dx will disappear. For correct notation, it will only be equal to, and then remember the coefficient of x is 1. We said if it is x to the power 1, we take the coefficient. You still remember that, grade 12? And then now here is 3 over 2 times 16, and then x exponent 3 over 2, we subtract a 1, plus exponent 2 times 64, and then x from the exponent we subtract 1. That is the method. And then from here we have that 1, we are done with this. And then down for the second one, we are having 3 over 2 times then 16 divided by 2 is 8. 8 times 3, that is 24. Then this will be plus 24x. And then 3 over 2 minus 1, you'll be left with a half there. And then plus 2 times 64, that will be 128. And then x to the power 1 because we have 2 minus 1 there. Then that is your derivative, grade 12. So the first answer will be for correct trinomial here at this level. And then the second mark for derivative 1, derivative 2, derivative 3. Therefore, this program will work 4 marks. Can you see now, deriving each term correctly, if the mark is independent, you'll be having a mark for each derivative. Right. Now we are still in differential calculus. We are now looking at the equation of a tangent. Remember, a tangent is a straight line. We are using the same equation of a straight line. Y is equal to mx plus c. A tangent is a straight line. So when we are looking for the equation for that, we still use mx plus c. Or you can use y minus y1 is equal to m into x minus x1. It depends on the formula that you are used to. Okay, so don't forget, a tangent is a straight line. And we know that in order to find the equation of a straight line, you need a gradient symbol m, and then with a point that lies on that particular line. Okay, if you can have those two happy, you can now determine the equation of a line. Right, let's look at the given information now. We are given g at x is equal to 3x squared plus 9x. If you look at this equation, this is a parabola equation, positive, concave up. And then number 1, you need to determine the derivative g at x of that particular equation. Remember, you are using the rules now. No first principle now. We are using the short way, which is application of rules. Let's hit the road, grade 12. And then now we have the first one. The notation is g, derivative of x. Remember, is 2 from exponent there. 2 times 3, x. And then from the exponent, we subtract 1. And then this one is x to the power 1. We said if it is x to the power 1, we take the coefficient as the derivative. And then now, finally, we are having 2 times 3, which is 6. X, 2 minus 1 is 1 plus 9. Therefore, that is the G derivative equation. Okay. And then number 2, determine the gradient of the tangent to the curve of G at the point where x is equal to -3. Now, grade 12, the minute you derive, you are now looking at the gradient of a tangent. That means the gradient of the tangent will be represented by this equation, 6x plus 9. The minute you derive, you are now determining the gradient of a tangent. And they say now, number 2, determine the real now gradient, the value of that gradient when x is equal to -3. So we are taking m of a tangent, gradient of a tangent is equal to 6x plus 9 from this information from number 1. They were supposed maybe to add a hence here to show that you need to use the previous answer. And then now we are going to substitute our x with -3 so that we can get the value, the actual value of our gradient. Then this will be 6 into -3 plus 9. That is -18 plus 9, which is giving us a -9. This will be -18 plus 9, which is -9. That is the gradient of the tangent. Can you see the gradient is negative? Obviously, if the gradient is negative, we are expecting the line that is decreasing. Okay, when you have to sketch this by just looking at the gradient, therefore it is minus. When you minus, you are reducing, you are decreasing. Therefore, the graph will also decrease for that particular line. I am now bringing in your functions. Okay, and then now number 3, hence determine the equation of the tangent to the curve of G where x is equal to 3. Now we need an actual equation of this tangent line. So we said when you need the equation of a line, you must have a gradient and a point. Happy, we have a gradient which is -9. And then with the point, we have only the x value. So if we can maybe find the value of y, then we will be able to have a point. We can't go to the formula before we have a gradient and a point, grade 12. Right, let's look at the y value now. We can take this x and substitute into the original equation. So that will be G at -3 from that equation, and then equals to the 3 into -3 squared plus 9 into -3. And then if you put this into your calculator, now remember this is representing the y value for that particular point, and then this is giving us the y value that is equals to a 0. Okay, that will be -27. Yes, that is +27. So y will be 0 now. Now we are having m tangent, gradient, yes, is -9. We have a point, x value -3, and the y value is equal to 0 there. Then grade 12, we have all what we need in order to find the equation. So the equation is y equal to mx plus c. Then this point here will serve as our x and y. What is y? 0. What is m? -9. What is x? -3. The aim is to find the value of c then. And then this is 0 minus 9 times 3, 9, 18, 27. And then that is c. Therefore, c is equal to, you transpose 27 to the left, that is -27. We now have the c value. We can now write down the final equation. Y mx plus c is the original. When we now write down the final equation, we leave y and x. We substitute the m and c only. So this will be equation y equal to m gradient minus 9. We leave x, and then now we now substitute the value of c, which is -27. Can you see grade 12? Gradient and a point in all, even in your function. When you are looking for the equation of a straight line, remember a tangent is a straight line. The method is the same. You must have a gradient and a point in order to win that particular question. Right. And then now moving on, we are still on differential calculus. We now look at the cubic function. Remember, when you talk cubic function, we are talking the graph that is having two turning stationary point or turning points, which is the maximum and the minimum turning point. I hope you still remember that. With the original equation, y is equal to ax squared plus bx, ax cubed plus bx squared plus cx plus d. That is the original equation for a cubic function. How do we know it's a cubic function? It must have x to the power 3. Therefore, it is having 3 values of x if the other value is not a turning point, okay? Right. And then now number 1. You are given a function that this function is defined by f at x is equal to, can you see it's x cubed, therefore it's a cubic function, minus x cubed plus 6x squared minus 3x minus 10. And then grade 12, lucky enough, this is partially factorized for you. They have already found the first factor for you, and then the trinomial factor. Yours is to find the factors for the second one in order to find your x-intercept. Isn't it? Okay. But you know that if nothing is given to you, you must apply the factor theorem by substituting 1 minus 1, 2 minus 2, 3 minus 3 until you get the correct factor. From there, you can use a synthetic division, your long method, or that inspection short method. So those are the 3 possible methods in order to be able to find this factor here. Okay, lucky enough for this one, the factor is given to us. Right. Now with the first question, they say write down, right? The minute they say write, they mean the answer is there. You don't need to calculate anything. The answer is given to you. They say write down the coordinates. Coordinates, that means in the form x and y. Ne? Look for those keywords, grade 12, in order not to go wrong. We write down, that means the answer is there. What are we writing? The coordinates, that means the x and y of the y-intercept of f. We are writing the y-intercept in coordinate form, in the form x and y. So now, remember, when you look at the y-intercept, you let x equal to 0. So that means this will be 0, this will be 0, and the 6 times 0 will still be 0. When you put a 0 there, it will be minus 3 times 0, which is 0. That simply means now this whole part here is 0. What is left is minus 10. That is your y. So now if they write down, you can see that in order to get this minus 10, you let x equal to 0. Therefore, your x will be 0 because we need this in coordinate form. And the y value will be a minus 10. So that is the coordinates of the y-intercept of your graph. Remember, when you find y-intercept, you let x equal to 0. And then second question, show that x plus 1 is a factor. Show us that it is a factor. In order to be a factor, when you divide by that factor, you must get a 0. Or when you substitute your x with minus 1, it must give you a 0. Where does x minus 1 come from? We let this x plus 1 equal to 0 from there. And then now this will give us x is equal to negative 1. So in our expression, we are going to substitute our x with the negative 1. So we take f at x there. Or you can even use this part, you will end up with the same answer, right? And then now we look at f, where we are having an x, we are going to substitute a minus 1. This is equal to minus from f at x formula there. And then for x, we are putting a minus 1 cubed plus 6. For x, we substitute a minus 1 squared minus 3. For x, we substitute a minus 1. And the minus 10 there. And then if you put this grade 12 into your calculator, please always use your calculator. Ne? Don't rely on your own calculation. Verify with the calculator. And therefore, this will give us an f at minus 1, which is equal to 0. What does it mean now when it gives us a 0? It says, therefore, x plus 1 is a vector. We need to see that conclusion, grade 12, after calculating. Okay. Number 3. Hence, if they say hence, they say using the previous information, determine the x-intercept of f. Remember now, our equation is minus x cubed plus 6x squared minus 3x minus 10. And then we let this equal to 0, right? And then now, if you want to find the x-intercept, you let y equal to 0. Remember that. And then now, this is already factorized for us. We are taking those factors. Oh, negative was taken out. And then we have an x minus 2. Remember, we have just proven that another factor there must be x plus 1. No need to check for that. It is already there. Then it will be, okay, let's start with the trinomial factor first. X squared minus 4x minus 5 equals to 0. And then you have minus following the previous bracket here. And then now for this trinomial factor here, we are going to have x plus 1 as one of our factors. You just have to check for another factor now in order to have factors of 5. When you subtract, you get a 4. That will be 5 and 1. Can you see that? It will be 5 and 1. But we need minus 4 when you add them. That means 5 must be negative. So now, remember, this negative doesn't have any impact into your bracket. You can multiply by negative. It will still be a 0. So we will concentrate only on the x minus, will be x equal to 2, or the second bracket, x equal to minus 1, or the last bracket, x is equal to positive 5. Those are your x-intercept for that particular function. Okay, grade 12. Remember, we need these calculations. Remember, y-intercept is at minus 10. And then the x-intercept is 2 minus 1 and 5. Okay. Let's put this somewhere here. We have the y-intercept minus 10. We have the x-intercept at x equals to 2. Another x equal to minus 1. Or the x is equals to 5 from the previous calculation. We are still given that equation. We are still using the same formula as the previous. This is a continuation from the previous one. Number 4, you are determining the coordinates of the turning point. Coordinates, again, in coordinate form, that means the notation must be x and y of the turning points of f. For calculus, when you are looking at the turning point, of which we call them the stationary points, we are using the derivative. Can you see, grade 12? The derivative is playing a major role in differential calculus. Those rules of differentiation, please practice and practice and practice. Now, we need the turning point. When we want the turning point, we cannot use this part. Remember, before you derive, there must be no brackets, no variables on the denominator, no root signs on your questions. So now you can't take that part because it's having brackets. So we are going to rely on this one in order to find the stationary. Stationary, we said we are deriving. So we are going to derive the f function. And then the derivative of that is that 3 times, remember there's a 1 there, it will be 3 times minus 1, which is minus 3x. From the exponent to subtract 1, it will be to the power 2. Second one, 2 times 6, it will be plus 12x. And then from the exponent to subtract 1, it will be to the power 1. Remember, if it is initially to the power 1, you take the coefficient as your derivative there. And then if it's a constant value, the derivative is 0. Therefore, that is our derived formula, derivative of that particular f at x function. So you let this derivative be equal to 0. And then on the right hand side, you can simplify the equation by dividing by minus 3. Then if we divide by minus 3 here, it will be x squared. Divide by minus 3 here, it will be minus 4x. divided by minus 3, it will be plus 1. So grade 12, if you look at that trinomial, it is saying look for factors of 1. When you add them, you get a minus 4. There's no way you can get factors of 1 added being a minus 4, because factors of 1 are only 1 and 1. So there is no way, grade 12, that you can have factors of 1 giving you a sum of minus 4. So that means we are forced to use what? A quadratic formula in order to find the factors for that particular trinomial. So we go quadratic formula, x is equal to minus b plus minus the square root of b squared minus 4ac all over 2a. And then we have a negative from your formula there. And if you look at the b value there is having a minus 4 again, you bring another negative. That will be plus minus the square root of, what is b? Minus 4 squared minus 4. What is the value of a? A is 1, is the coefficient of x squared. And the value of c is that 1 there. And then all over 2 and the a value 1. So this will give us an x value. The first one will be 3,73, or rounded off to 2 decimal places. It will be stated on your question paper on the instruction sheet. And then this will be x equal to 0,27. That is your second x value. So in this case, grade 12, you only have the x turning point values. You also need to calculate the y turning point values. And then when you calculate the y turning point, be careful, do not substitute into this formula here. You need to go original f at x there and substitute your x 3,75 into this equation. Where you have an x, you will substitute the 3,73, and then for the next answer substitute a 0,27. So now when you substitute 3,73 into your calculator, you can even do it on your calculator, grade 12. There's no need to show us because there are no marks for that. And then now you'll end up with 10,39 positive for 3,73. And then if you substitute a 0,27, your y value will be minus 10,39. Remember, they said they need this in coordinate form. That means now for the first pair here, it will be 3,73 coordinating with 10,39. For the second bracket, it will be 0,27 coordinating with minus 10,39. Those are the stationary point or the turning point of that particular. And then grade 12, this is very important. After calculating your turning point, compare your y turning point and immediately identify the maximum and the minimum point, okay, by comparing the y turning point values, right? So this is 10,39 and the minus 10,39. So if we are comparing the two, you can see that 10,3 is the biggest one. That means this will be your maximum turning point. Can you see that? Maximum. And then this one is a minus. That means it will be the minimum turning point. This will assist you when you are sketching your cubic function. Okay. And then now move on to the next question, 5. We are now sketching our graph. Remember, this graph is a negative graph. A is negative there. If A is less than 0, meaning it is negative, we are expecting a graph that is starting concave up and end up being negative, facing downwards. Or it can be a smooth curve like that one. It depends on your calculations. So eventually the last arm must face downwards, okay? Because it's a negative value of A there. Now let's draw the graph now. Right. You need your y-intercept. Remember we said y is equal to what? Minus 10. Because it's an intercept, it must be on your y-line. Because it's a y-intercept, it must cut the y-line. And then remember, we have calculated the x-intercept from the previous question 3. So now this is x equal to -1. This is also an x-intercept. And then x equal to 2. Our second x-intercept. And lastly, we are having the third one at x equal to 5. Those are the 3 x-intercepts. And then now, can we now bring in our turning point? The graph is turning at 3,75. 3,75 is between 3 and 4 there. And then 3,75 is coordinating with 10,39. This is a pair. It is coordinating. You can't put a point on x, a point on y. Doesn't x like x exists, ne? And y exists. These ones are coordinating. At the point where they meet, it is where you are going to have your point. And then we have 0,27. Just before 1, we are having a 0,27 there. And then this is coordinating with -10,39. And then where they meet, you'll be having a point there. And then these are your stationary points. Look at the fact that I've given to you earlier on, that these curves here will assist you to be able to tell how is your graph going to turn. So we have indicated that at 10,39, this is maximum. That means we are expecting this graph to be like that there. Maximum. And then -10, that is the minimum graph there. Then you can just join. This must pass through 2 and come to that one. Going up there, passing through -10, up, cutting at -1, and then it will go through 5 there. Then this is the expected graph of that cubic function. Okay, that is the correct sketching. Remember, the notation there at the maximum and minimum will assist you. Lastly, on number 6 now, they say use your graph to write down the values of x. Okay, use your graph to write down the values of x. Our answer must be in terms of x because we need values of x. And then how are we going to get those values now? This statement is talking to you here. It is telling you that go to the graph and then at f derivative, remember a derivative is a gradient. So they say look at the gradient of this graph where the gradient is greater than 0, meaning where the graph is having what? A positive gradient. Remember now, when the graph is decreasing, check from left to right. The graph is decreasing. If you look at the diagram going down, that means if it goes down, that is a negative gradient. Decrease, the gradient is negative. Here it is stationary. From that stationary point now, the graph is moving up. That means the gradient is positive because the line is increasing now. And then it becomes stationary again at maximum. Immediately after maximum is going down, therefore it's decreasing, therefore the gradient will be negative again there. So the question states that look where the gradient is what? Positive. Where is our gradient positive? It's only at this portion here. So it is starting from which x value? Remember at that x turning point here, which is 3,73. Between these values of the turning point here, it's where this graph is now positive because we are talking to that portion there. Okay? And let's see now. It's where you are having x between, can you see it's between the two x values. The first one is 3,73 this side, and then with the 0,27. And they said that the x must be positive. Happy, all our answers are positive. That means we are safe because it says x must be greater than 0. Okay, so these are the questions that follows after your graph. You must be able to interpret them virtually using your graph. Right, and then the last topic on differential calculus, it will be optimization. In optimization, we will be having the optimization question or the calculus of motion, which is talking to velocity, acceleration, distance, and so forth. Or it will be optimization of shapes, the area of a cone, of a box, of a rectangular prism, and so forth. And then that is the application of the area, perimeters, and the volumes of shapes. And then now let's look at the one that is given to us here. The picture and the diagram below show a right cone shaped magnet. This is a magnet. It is crafted from a piece of a magnet. And then the right cone shaped magnet has following dimensions. So here we are having the actual magnet, and then here we are having a diagram that is representing this magnet in terms of the dimensions now. Now we have a radius which is indicated by R there, and then we have H, the height of that particular cone, and then now we have a slant height, which is that one, which is the hypotenuse side opposite to your 90 degrees there. And then this is a right cone shaped because it's having a 90 degrees angle at the center there. And then now they say express the radius R of the cone in terms of its height H. We are given the formula. The following formula may be used. We are given the volume of a right cone is 1/3 pi R squared times H. That is the volume of that particular cone. Then we are going to use that formula in order to be able to determine express the radius of the cone in terms of its height. Okay, right, let's start now. We are taking the volume formula, and then our volume formula is 1/3 pi R squared, and then with an H. And then we want to make what? R the subject of the formula, because we are expressing R in terms of H. So on the right hand side you want to be left with only H then. So how are we going to do that? We are going to multiply by 3 both sides, then it will be 3V there. When you multiply this by 3, it will cancel that one, so you are left with pi R squared H. Then we divide both sides by pi H. So pi will cancel pi, H will cancel an H. So on the right hand side we are left with R squared, and then the left hand side will be now 3V over pi H. But we don't need an R squared, we need R because it's only R there. So this will lose an exponent too, then because it's a radius, it's a distance or length, then it will only be positive, right? So we are taking the square root of that. If it loses 2, it will gain a square root on the left hand side. That is 3V over pi H there. So that is our R value. So R is equal to the square root of 3V over pi H. Okay, and then now number 2. Hence, that means using the previous answer, show that the volume of the cone can be expressed as V into H is equal to that formula 3 pi H minus 1/3 pi H cubed. Okay, we want to express this in that format. All right, and then where do we start now? If you look at this one, there is no R here. Can you see that? That means the R is being substituted by something, grade 12. Okay, so now we are going to start by finding the R. Remember, R is in this particular triangle here. We are going to find R in terms of the height and the length and so forth. Let's start with that R because there's a 3 pi something there. That means this 3 is being used somewhere there. So now we are going to start by using Pythagoras. Remember, if we are looking for R in this case, is not the hypotenuse, it's the side. Ne? The hypotenuse side is that L. So we are going to say L squared is equal to the sum of the two sides, which is the R side plus the H side. Okay, what is L? L is 3. That will be squared. And then we are looking for the R in terms of H and 3. Then this will be R squared. And the H is how much? That is H squared. And then now this R squared will be 9. 3 squared is 9. and then we transpose h squared minus h squared, and then we are having an r squared. Can you see that, grade 12? And then from here now, we are going to take this into our expression here, right? Where we are having a volume. Remember the question says write the volume in this format. Let's see now. We were given the volume being 1 over 3 pi r squared multiplied by h. We now substitute the r squared with 9 minus h squared. It's 1/3 pi. For r squared we put 9 minus h squared, and then there is another h there. So multiply in, we can take this h and bring it here because it is all about multiplying, grade 12. So that will be 1 over 3h times 9. So 1/3 of 9 is 3. That is 3 pi h. We are distributing this to 9. And then secondly, the whole thing again multiplied by h squared. That will be minus 1 over 3 times 1 is 1 over 3. And then we have a pi, and then h by h squared, this will be h cubed. Can you see? That is exactly what is expected of you in terms of volume, in terms of h. Alright, that is your number 2. Number 3, never be confused, grade 12. I know most learners will be taking this r, trying to substitute into that formula. It will not work because this r was derived from this particular formula. So there's no way you can take that r again and substitute into that same formula again. Otherwise, everything will be cancelled. That is why we opted for another method to find the value of r. Okay, and then now look at number 3. In order to find number 3, now let's check. Determine the numerical value of h. We want the real value of h now. Numerical value of h for which the volume of the cone will be maximum. The minute we see the word maximum, they are telling us find the value of h by deriving the formula. Okay, now we take the formula for the volume. All right, and then we are going to use this one from number 2. This was also supposed to be a hence question because we are going to use that one. So it is saying v of h equal to 3 pi h minus 1/3 pi h cubed. Then when you derive this derivative of h, right, remember we are deriving in terms of h. Okay, so h is h to the power 1. We are going to take the coefficient, that is 3 pi. And then for the next one is 3 times 1/3, that is minus 1. And then pi h, we subtract 1 from the exponent. Can you see the rules are playing a major role in differential calculus? We are still applying our rules, grade 12. And then from here now, the same method as we were doing with stationary. Remember, with stationary point, after deriving, you let the derivative be 0. The same applies here. We let the derivative be 0 there. And then we have 3 pi minus pi h squared. We are looking for this h. So we are transposing this because it's a negative part so that it becomes positive h squared equal to 3 pi. Then we divide by pi both sides. Then we are left with h squared is equal to 3. Then h will be equal to plus minus the square root of 3 there. So your answer will be h equal to plus minus, our value will be 10,88 if we look at the real value, not in a set form, rounded off to 2 decimal places. So we were determining the numerical value of h. Then now we are excluding a minus. We cannot say the height of this cone is minus 10,88. No, there's no way the height can be a negative value. So therefore, we are going to conclude that the final value of h will only be of positive 10,88. So you are discarding the negative one, or you can write h equal to minus 10,88 is not a solution. It must not be equal to that one. Okay. And then now, lastly, we are having integration, which is, remember, differentiation and integration, they are clustered together as 50 plus minus on your paper 1 in terms of the marks allocation. So when we are integrating, we have two types of integration. There's a definite integral and the indefinite integral. When you talk definite integral, it will give you a definite value of that integral. And then now the integration is the reverse of differentiation. We are taking it back to its original now. Now, a tip around differentiating, you look at the question. Look at the question. Here they say determine the following integrals. You look at the question. These formulas are at the back of your question paper. And then you check now which rules goes with that one. Is there any integration between your rule? If you look at that one, it goes with this one. Can you see? There's a constant value over x there. So the answer is already there for you, grade 12. Yours is to put your k. What is your k here? Your k is 3. And then the in of x, you are done. So when you give me the answer for that one, you'll say, oh, this will be equal to 3 in x plus c. Done. That is your answer. So now you need this table to make your life easier in terms of relating your integrals with the formulas at the back. If you have this formula next to you, it's very easy to do integrals, grade 12. And then with the number 2 now, there are complications. Remember, this applies the same rules as in differentiation. No variables, especially if it is not of x to the power 1. X to the power 1, we are applying this rule. But the minute is 2, 3, and so forth, greater than 1 in the denominator, that means you need to do something. Apply your exponents there. So now we'll leave this as being an integral because we want to simplify the bracket. That will be minus 3. We are dividing x to the power 1, x to the power 5. We subtract the exponent. That will be 1 minus 5, which is x to the power minus 4. Plus, we don't want sets. This will be written as x to the power 3 over 5. And then remember, this is still a dx. We have not yet integrated. So now we can now start integrating. With integration, remember, is exponent plus 1 plus 1. Ne? Is not minus 1 as in differentiation. Grade 12, do not mix the two. When we integrate, we add, right? Then this will be minus 3 x to the power minus 4 plus 1. And that exponent also goes to the denominator, minus 4 plus 1. That is integration now. Plus x 3 over 5 plus 1. And then that exponent also goes into the denominator. And then this will be plus c because we have now Can you see now the integration sign is no more there because we are integrating. So we'll end up with minus 3 x to the power minus 3 and denominator minus 3 there. And then plus x to the power 3 over 5 plus 1, that will be x to the power 8 over 5. And then denominator will still be 8 over 5 plus c. So correct notation for the final simplified answer, minus 3 will cancel minus 3. We are left with x to the power minus 3. And then this one, if we write it correctly, it will be 5 over 8. And then x to the power 8 over 5 plus c. If you are not sure, grade 12, leave it like that rather than mess up there. Okay. And then now we have, I think this is the last question on your question paper, where we are looking at the area below and above the curve of the bounded area now. The integration area bounded by the curve. It's where we are talking the definite integral because we are given the values that we are integrating within these intervals. With the integration bounded by the area, if it is below the x-axis, the area will be negative. Above the x-axis, the answer of your area will be positive. Let's look at the question now. The sketch shows the function of f at x is equal to x squared minus 5. As you can see, we are having a positive parabola graph there. And the two shaded areas are represented. The two shaded areas represented are area 1, the area bounded by function f, the x-axis and the ordinate between x equal to 0 there and the x equal to 3. As you can see, we are talking to that area, grade 12 there. And then since it is below, that means it will be a minus area. And then now area 2 is area bounded by function f, yes, between the x-axis and the ordinates x equal to 5 and x equal to 7. Then we are talking to that area now. And then this area is above, therefore it will be a positive area now. And then the question says that determine by showing all your calculation by how much is A1 greater than A2. That means we need to calculate the area 1, calculate the area 2, and compare by how much is A1 greater than A2. So let's start with area 1. So now in order to calculate this area now, we need to integrate the equation that is given to us now. Okay, so we need area 1. So we are looking at the integration of x squared minus 5x, but this is bounded now between 0 and 3. So on top here we are writing the bigger number, and then below is the smaller one. And then since this is the below the x-axis area, it must be a negative area, greater. Okay, and then this will be minus. We are now integrating this value here. Then remember, integration is plus 1 plus 1. That will be x to the power 2 plus 1, which is 3. And then that exponent will also go on the denominator. And then minus 5x. This is to the power 1. It will be plus 1. That is 2. That 2 also goes to the denominator there. And then with those with the square bracket, we now put in the ordinates 3 and 0 there. Continue. We are having a negative. And then we are now going to substitute now. Start by substituting a 3 for x value. That will be 3 to the power 3 over 3 minus 5 into 3 to the power 2 over 2. And then minus, look at that negative, it is still there. Can you see that I put a bracket that is taking care of the negative out there? And then now inside we started by substituting a 3. We are now going to subtract and substitute a 0 now. That will be 0 to the power 3 over 3 minus 5 into 0 to the power 2 over 2. Then after doing this, we don't indicate those ordinates anymore. So if you look at this bracket, it will give us a 0 there. And therefore we will be left with this value here, which is 27 over 2, of which is equal to 13,5. That is the area 1. Now let's look at the area 2. We are still using the same integral, which is x cubed over 3, but this one will be positive now because the area is above. X3 over 3 minus 5x squared over 2, but this is within the ordinates 7 and 5. Okay, substitution. We are still looking at A2. We are going to substitute 7. That will be 7 cubed over 3 minus 5 into 7 squared over 2. And then minus, we now substitute a 5. That will be 5 cubed over 3 minus 5 into 5 squared over 2. You close. You don't write the ordinates anymore because you have substituted them. Then everything into your calculator, grade 12. Do not do the partial calculations. And then this one will give us a 12,65. In a fraction form is 38 over 3. And then in decimal it will be 12,67. Then when you look at the difference between the two areas, it will be the biggest area, which is A1, minus the smaller one, which is A2. And then that is 13,5 minus 12,67. And basically this will give us a 0,83. And then grade 12, this brings us to the end of today's lesson, which was brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery. All the best with your exams, grade 12. Thank you.